All right, so we are about ready to move into the next group of functions that we've looked at. Linear functions, quadratic functions, which were all examples of polynomial functions. Now we're going to talk about rational functions that we'll see are that include all these other functions. Okay, so maybe you've heard of rational numbers before. Rational numbers are a fancy way of saying fractions. So 4/5, -7/11. Those are certainly fractions. So they're rational numbers. 6 is also a fraction because it can be written as 6 divided by 1, right? All right. So those are rational numbers. Now they're just fractions of integers. Rational functions are fractions of polynomials. Okay. So basically, we can take one polynomial and divide by it some non-zero polynomial, and then that is just going to be that's a rational function. Now, rational functions, they are kind of like polynomials, but they're not. We're going to see that they behave nicely except when the denominator is 0. And when that happens, one of two things can happen. We can see the graph can literally shoot off suddenly, and either shoot up or shoot down, or it can, or maybe in some degenerate cases there might be like an open point. Okay. We also see that unlike polynomials, these graphs do not have to shoot up or down. They can level out somewhere. And I want to just look at the first example of a graph, and what we're going to be doing in the next section is learning how to graph these rational functions without looking at without using a graphing calculator. For example, so in this example, y is where the graph is defined by y equals x minus 1 divided by x plus 2. That's certainly a rational function. It's a fraction of polynomials. And we can see that two things are happening here that don't happen with polynomials. We have a vertical asymptote at -2. And notice that the graph is not crossing this imaginary vertical line at -2. Okay, and the reason for that is if you try to plug -2 into here, you get -3/0, which is undefined. Okay, and if you plug in numbers that are close to -2, they're either going to be very, very large numbers, positive numbers, or very, very large negative numbers. Another thing you can see here is that the graph levels out along this line at 1, this horizontal line at 1. That's called a horizontal asymptote. And in this case, it never crosses this horizontal line either. And from here, we can see that what we have, so we call the vertical line a vertical asymptote and the horizontal line a horizontal asymptote. And we can see that from here, because the graph never crosses this vertical line at -2, -2 can't be in the domain, right? There's no point on the graph where the x-coordinate is -2. And there's also no point on the graph where the y-coordinate is 1. So we can see that 1's not going to be in the range. So that's why the domain is everything except -2, and the range is everything except 1. And we don't necessarily have to look at the graph to figure this out. We can see, obviously, as I said before, we plug in -2 here. This is undefined. And if you try to set this fraction equal to 1, the only way this fraction can be equal to 1 is if x minus 1 equals x plus 2, which you can see will never happen. So these are the kind of functions that we'll be looking at in the next couple of sections.